Good afternoon, everyone. Am I audible? Am I audible?
Yes, ma'am.
Okay. Okay, so this is your structural engineering class. I think we are doing the class today. So we have this is your structural engineering PCC CE303. Okay, we'll be doing this. This is a 3 credit subject. I'll show you the syllabus. Wait, let me share my screen. So this is your syllabus, okay? Subject code is Pcc-Ce303 Structural Engineering. These are your syllabus. There are 5 units. Okay. 5 units are there. First will be your introduction, the basic normal about structural engineering. What is structural engineering? What are the different roles of different engineers, architects, users, builders, all those things. Then second is about the material laws, design safety. Okay, properties of concrete and steel, wind, earthquake loads, all those things. Then we have the third unit. We'll talk about the analysis of your determinate and indeterminate structures. Then fourth is this is your fourth one. In the fourth, we are going to do the designs. Actually, you know what? This was before it was in design of structures 1, 2, and 3 like that it was, no? But nowadays in syllabus has changed. So in this structural engineering only, all these things are given together. So that is why these design parts are also here only. Design parts are all together here. So let's see how shortly we can go and discuss about all those designs of different beam, columns, etc. Okay, RCC structures. Fifth is your special topics that may be covered as part of design. Yeah. In the fifth one, this fifth, basically most important one is this three. Three and four is only the most. Others are also important, but the most important one is this three and fourth one, and the fifth one is for your discussion of any special topics like for your future this thing na, in your final year projects and all. What are the different topics, etc., which we can take? Those things can be discussed here in your fifth unit. Okay, so this was your top. These were your units. Total, since it is 3 credit, so 30 classes should be there. Then we have this books. Sorry, huh? This one I think we have. I'll refer Ramamuttam. You can refer. Okay, not steel one, but the RCC Ramamuttam. You can refer to that book. So let's start with the introduction today. If I let me, yeah. So if we go with the introduction, today, I think 2 classes we have. Let's see how we can proceed. So basically, what is your structural engineering? Your structural engineering, wait. Your structural engineering is a field of engineering, okay, which is dealing with what? Analysis and design of structures that support or resist loads. Okay, structural engineering basically means how you're going to, what is the analysis and design of the different structural members like beams, columns, etc. Okay, so but before that we should know some of the important things also, like the loadings, what are the indeterminate determinate structures about forces, etc. Okay, so structural engineering is usually considered a specialty within civil engineering, but it can also be studied in its own right. Okay, so okay, structural engineering, you know, now that means the it is a study of the analysis and design of the structural members or different structures, or about different structures you can study on that structural engineering. Okay, now what does a structural engineer do? A structural engineer will analyze. Okay, mm, okay, so we have what structural engineers can analyze. And basically what your structural engineers are going to do is that they will analyze the structure, design the structure, planning will be done, and there can also be structural engineering engineers on their further studies. They can also do what? They can do the research of the structural components and the structural systems to achieve the design goals. That means the safety is this thing, no? The safety of that structure is also analyzed such that they can give you the they can be your structure can have a life of the design period, like for how long it has been designed, for how long your structure is going to be stable and without failure it can give its service. So that is your design goal. So the structural engineer will always try to achieve these your design goals and ensure the safety and the comfort of your users or the occupants. Okay, so there works. So before we can start with our structural engineering designs, so what we are doing, we are just going through the basics. We are going to the some theory portions before we go to the designs of the different members or the design of the structures. Okay, so this is what a structural engineer do. Then we have their work takes account mainly of safety, technical, economical, and environmental concerns, but they may also consider aesthetic and social factors. Okay, now we have what the structural engineering specialities for building include. They can be your earthquake engineering. Okay, then we have the fire engineering, roof engineering. Sorry, so it can be your roof engineering. Then it can be your tower engineering. Okay, hello. Okay, so it can be your tower engineering. It can be wind engineering. The structural engineering can be done in this. Okay, and this one. Okay, this is your FAC. Okay, facade engineering. This, like earthquake, it will be basically dealing with your dynamics of the dynamic motions, like your earthquakes, how your earthquake designs should be. But this is not in your this fifth semester. Okay, this will be in your higher s- semester, like for 7th sem or 8th sem, like that. Okay, so earthquake engineering will be there in your 8th semester. So facade engineering, this will be dealing with your art and science of resolving your environmental and structural. Wait, where is my, yeah, this will this is your facade engineering is the art and science of your resolving the aesthetics. That means for environmental and the structural issues to achieve the effective enclosure of the buildings. Okay, then fire engineering, that will be dealing with your fireworks. Then we have your roof engineering, tower engineering. These are your different civil engineering structures, which can be, these things: bridges, dams, earthworks, foundations, offshore structures, pipelines. Engineering, civil engineering is everywhere. In these structures are where we can work as a civil engineer. In railways also, the structural, civil structural engineering works are there, retaining structures and walls or roads when you're building a road, tunnels, waterways. Okay, and the watershed, like the water pipelines, etc. For those also, civil engineers. These are also, these all are your civil engineering structures where we can, your civil engineers are required. Okay, structural elements. These are your different structural elements, which is your, okay, structural element. These are your different any structure which is essentially made up of only a small number of different types of elements. These are your what are the elements that make up your structure is what? These are your columns, beams, plates, arches, cells, catenaries. Okay, so these were your simple, just the slight introduction to your what are the structural engineering, what is structural engineer, what they do, all those things. Okay. I think I have shown the syllabus. Syllabus I have shown. You can use Yamamoto also for your RCC designs. Then we have I have done with you people the normal structural engineering theory portion. Now let me go to your first unit. In short, I'll just go here. Wait, let's share. So, in short, if I show you this slide, Introduction to Structural Engineering, what does this say? Okay, this is your what? In the structural design is a systematic and interactive process that involves identification of intended use and occupancy of a structure by the owner. Okay, so in the first chapter these things are only there, that is your basic introduction, then who does what. Okay, there are different processes when we do the designing of structures. When we do the designing of structures, there are different processes or there are different steps. So what are those is that the owner will be looking, what the owner will be identifying the intended use and occupancy of a structure, like how many people are going to stay there, whether it is a flat made or whether it is just a ground floor G plus one building, how many people are going to stay there. So that depends upon the owner. So when we these are the basic designing. When before designing, what we do before structural designing, this is the owner's duty. Then we have the architect. What the architect is going to do, he is going to do the development of the architectural plans and the layout. Okay, and by the engineer, what the civil engineer is going to do, he is going to identify the structural framework, like what are the beams, how much load is going to fall, how much load is going to fall on each floor, on each beam. Okay, so how much materials are required, etc. um, how much are the dimensions that are to be given, all those things, and the analysis, all those are done by your civil engineer. Then we have the estimation of the structural loads depending on the use and the occupancy. So the estimation is also to be done by the engineer. So this is also done by the engineer, and that can be done what, after your the owner knows the occupancy also. So when the owner knows about the occupancy, obviously then we know how many number of floors are there, how much is the dimensions of the building. So in that respective to that, with respect to that, the estimations can be done for your structure. Analysis of the structure to determine the member and connection. design forces, all these are to be done by the engineer. Design of the structural members and connections. Verification have to be done. Suppose you have designed the structure, the design the building, then you have to do the verification of the designs also to be done, like whether the according to the IS code, the required or the limitations which are there in the IS codes and all the rules or the things which are specifications which are given according to the IS code, what are to be done is followed or not, whether it is safe, the factor of safety is there or not, so is maintained or not. All those things are to be verified after the design and the analysis is done. Then the verification and erection by steel fabricator. Then comes the steel fabricator and the contractor, the fabrication and erection of the members. Then inspection and approval by state building official. Ideally, the owner and the architect and the engineer and the fabricator or contractor will collaborate and interact on a regular basis to develop, design, and build the structure in efficient manner. The primary responsibilities of these players are as follows. That means the engineer, architect, fabricator, contractor, all those things they have to be followed. The owner primary responsibility is deciding the use and the occupancy and approving the architectural plans of the building, the owner's duty. Then the architect, what they will do is going to do the primary his responsibility is to ensure that the architectural plan of the building interior is appropriate for the intended use and the overall building as is aesthetically pleasing. Okay, whether it is externally, internally, all those interior portions also are going to be checked and ensured by the architect. Then we have the engineer. The engineer's primary responsibility is what? To ensure the safety and serviceability of the structure. Obviously, since the engineers are going to design according to the Indian standard codes, so the designs, the responsibility of the engineer is to ensure the safety and the serviceability of the structure with your design. Then the fabricator's work is to primary responsibility is to ensure that the design members and connections are fabricated economically in the shop or field as required. Because when you do the fabrications will be required in your some of the steel works or the teak works, etc. Okay, so if I show you. Now we can go in detail about your structural engineer. Structural engineer analysis and design the gravity support and lateral force resistance of buildings, bridges, and other structures. Okay, so the structural engineer we have talked about the engineer. Basically, we were talking about the civil engineering works, like where they can work. They can work in making your structure. Okay, that's civil engineering. That is your structural engineer basically. The structural engineer is what? He will create the drawings and specifications. Okay, he will create the drawings, the specifications, okay, calculations, the design, the analysis. Okay, all those things will be done by your structural engineer. But there are different engineers like for water resource engineers it can be those will be dealing with the water resource like the pipelines for PHE, for the sewage treatment plants, water treatment plants, etc. But the structural engineer basically they will be dealing with they can be dealing with your structural, the structures, the design, and the formation or the analysis, calculation, and the building up of the structure is done by your what? By your structural engineer. Then what they are doing, they have to analyze and then design the basic task of, again it is given in details like how they are going to analyze the basic task of the structural engineer related to numerical quantities. Wait, give me 1 second. Okay, so okay, so what happened? Yeah, we were talking about this one, analysis and design. Huh? The basic task of what is your civil engineer? It is related to your numerical quantities. Okay, numerical quantities of physical forces to physical configurations of forces resisting elements. Okay, so basically, when you're designing the civil engineering structures like beams, columns, etc., what you're going to do, you will be obviously dealing with the forces, moments, resistances, all those things you have to know. So you'll come to that. Analysis is the process of determining the forces in each element in the structure. Yeah, all this like beam and all I have talked about that. Okay, then we have the gravity support and lateral force resistance. Structures are subject to vertical or gravity loads and horizontal or lateral loads. Gravity loads include, yeah. So when we do in the second unit we are going to talk about the loads according to IS code, etc. But this is a rough, in short, if we talk about the loads, like basically you know what your structure is going to have. It's going to have lateral loads. That means your horizontal loads are also going to be there. That means your dead load of the structure. Suppose this is your structure. Your structure will have your dead load. Okay, so it is going to have your dead loads, which is your gravity load. Then you will have what? You will have your lateral loads in such like wind forces, the earthquake forces, etc. Okay, so gravity loads include your dead load or the permanent load, which is the weight of the structure. Permanent load means what? It is nothing but the load of the structure. Now what will be the life load? Life loads are related to your those loads which are changing. Okay, that means like suppose the things inside your house, the persons living there in the house, those are all your life loads. Okay, these were talking about the dead load. Dead load means what? Nothing but the structural load, the load of the structure or the structural members itself. But the life load is what? And the mechanical system and the life load or temporary load. Life loads are your temporary loads. That means it is increasing, decreasing. It may be zero, it may be more, because but the maximum is taken into consideration before we design the member of any structure. Okay, so these are the two different loads. That is your dead load, that is a permanent load, and the life load or the your temporary loads. Lateral loads also can be included. Those will include your wind, earthquake, or the explosions I told you. Like these are your lateral loads, earthquake loads, wind loads, etc. Structural elements must be designed so that as a system, the structure can resist all loads and that will act upon it. Okay. So we have building, bridges, and other structures. Structures are any system that resists vertical or horizontal loads. Structures include large items such as skyscrapers, bridges, and dams, as well as small items such as bookshelves. These are your simple, normal that resist your vertical and horizontal loads. Okay, those structures include your what? Large items like these. Mostly every structures are designed by testing or trial and error, with large, unique, expensive structures that are not easily tested are generally designed by a qualified structure engineer. Okay. This now in the syllabus, I think there was like the different job functions of the different job functions, like for your uh, different job functions are there for different job titles, against different job titles. Okay, so like for system engineer, they'll be doing for your what on CSC programs, etc. So there can be quality control engineer, system engineer, design engineer, test engineer, quality control engineer. Quality control engineer, like they will be testing the material tests. They are known as your quality control engineer, packaging engineer, help is okay. So there are various, in the engineering job, especially in the field of your these. Um, Okay, so there are different job profiles or job titles. Like for designer, the design engineer, what he is going to do, these things I think you can go through and you will easily know itself, but you should know like who is doing what. Like for when you are assigned or when you are given the designation as a design engineer, you are known as design engineer, your title is job title is design engineer. What you're going to do, just design specific parts of a system or components. Field engineer installs and operates equipments in its end. Okay. The field engineer, what is the work of this field engineer? They will install and operate. Okay, they will install and operate equipments in its end use environment, monitors for operational problem, and install needed system upgrades. Okay, that means when a field engineer, what they are doing on the field, they will go and they will check and monitor the things like suppose the laymen, the workers will be working, right? Laborers will be working for you. Okay, or different like quality control engineer will check the test the material qualities. Then the for field engineer, what is the job function of him? His job function is what? He will be installing, operating the equipments. He will be helping in those things, and as well as They will be monitoring like the work is going properly or not, whether the laborers, these laborers doing properly their work or not, whether the procedure which they are following is okay or not. These are the duties. If there is any problem also that arises, that will be checked or tried to be solved by your field engineer and will be monitored by this field engineer on the field. Okay, so this was the job profile of your field engineer. Now, what does your logistic engineer do? Your logistic engineer, these engineers will manage the aspects of the life cycle, support of systems, including spares, allocation, repair strategies, and cost of preventive and corrective maintenance. Okay, logistic engineer, what is his work? Okay, when there is any kind of this, field engineer will be monitoring, right, like whether there is any problem in the structure, or whether not structure, sorry, when they are, when the construction is on process, whether the constructional process is going smoothly or not. But in case of suppose any problem that arises, or there needed to be some repair works of the machines, okay, etc., so that cannot be done by the field engineer. We don't know the, suppose a particular machine, like suppose a crane excavators, as we were talking, oh sorry, I was not talking to two people, but there are different for suppose you are doing the excavation now in the same site, on the side itself, okay, there you need another flat you are constructing on the same plot. Okay, so you need to do the excavation. What you're doing, you can be using um, this thing. The excavators will be there. Different types of excavator will be the crane, shift foot roller. Rollers will be used for compacting that excavations. Okay, to compact the soils. But for excavations, there are different types of excavations where you a wheel, then we have a wheel-based excavation, crane excavation, extra where there is crane also. So when that gets defected, or there is some requirement of any repair works, then these are done by your, the strategies are made by your logistic engineer. Okay, so next is your manufacturing engineer. What does your manufacturing engineer do? Okay, they will use the knowledge of production and fabrication process to determine how best to take a given product or system design from prints and drawings into production into factory, including selection from completing process that could be used as a well, determine what production elements should be outsourced to other suppliers with specialized capabilities. Okay. So the manufacturing engineer, what is the duty of your manufacturing engineer? What he is going to do? He is going to on the field, whatever is, suppose there are some limitations. Suppose you are thinking this cannot be done with the help of this machine. So you need to improve that machine. Then this manufacturing engineers, what they are going to do, they are going to take some idea, they are going to take the need of that particular work. Suppose this work is to be done, but in the excavation, suppose I'm talking about compaction, suppose. Okay, so compaction as well as removal of the waste or any extra waste which is present on the site. You need to clean that. So when you give some workers or laborers, it will take more time. But suppose you're using a machine, so sometimes this, okay, there is 5 minutes. So I'll wait. I'll just share you the attendance link. Go to the attendance link and click the link. Again, I have next class. Join in the same link after 5 minutes. Okay, I'll share in the group only. Okay. Now I'll let me share the link here. Wait. In the chat box, I'm sharing. Okay, where it is. Email name, enrollment ID. Oh, sorry. I have given the link in the chat box. Okay, you can go and give the attendance.
Hello, ma'am.
Hmm.
Should we leave the class?
Yeah, yeah. But after 5 or 10 minutes, you join again. I'll tell in the group. If you have given your attendance, you can leave.
Okay.